Hello, today we're talking about mineral resources. So this is chapter 15 in your textbook if you'd like to follow along there. So when we talk about minerals, we're talking about substances with a specific chemical composition, and they have characteristic chemical and physical properties as a result of this. So these are either pure elements or they're pure compounds, which you should remember from chemistry are different combinations of these elements. So here are some of the different compounds you might see here. These native elements are those pure ones. And these form minerals. And there are three basic groups of minerals: metallic, non-metallic, and fossil fuels. So metallic minerals are the metals, the things you tend to think of that are good conductors like copper, iron. Non-metallic minerals tend to be good insulators. They act a lot of times as semiconductors, so things like silicone, gemstones, salts. And then we have fossil fuels. Fossil fuels store lots of energy in those hydrocarbon bonds. So for example, coal and oil, and we're going to talk about those a lot more later, so we're going to somewhat ignore them for this portion of the unit. So there's also something called a mineral resource, which is a little bit different than a mineral, but it will involve minerals. So it's when we have this mineral in the Earth's crust that we can extract and we can use for some sort of material, and we can do that at a very affordable cost, then that would be qualified as a mineral resource. And there are four major categories of mineral resources: identified, undiscovered, and reserves, and then other. So identified mineral resources, we know where they are, we know how much we have, we usually know something about the quality of that resource, we can actually measure it. So these are the ones that are most likely going to be exploited and mined. Then we have undiscovered mineral resources, where we think that there's probably a supply there, but we don't actually know for sure that that's the case. We have reserves, which are resources that we know are there, but we're not currently exploiting. So we're not mining it, we're not harvesting it. So you'll hear a lot about things like oil reserves, which means that in the future we could use that resource, but we don't right now. Right? So most of your resources that are going to be mined are going to be those identified ones, and we start off with the ones that are already in production and then eventually move into the reserves as needed. So here are some important mineral resources for some examples. So these are some things that you can find them in, some uses that we have for them. And you want to make sure that you record a whole bunch of different ways that we use minerals, because this is something that you should be aware of. You can see that they're found throughout your home in many different products, from the glass in your windows to the copper in your pipes, your paint and your drywall. Pretty much every part of your home has a lot of minerals in it. And if you just take one particular room, this is just an example with the kitchen, you can see all the different ways that we use minerals just in this one room. So mineral resources are extremely important. If you start to look at this graph, this shows you our mineral use in various ways. So most of this is those primary metals, most of it is the construction materials, and you can see that construction has grown over time as more and more development comes up. And then you also see the industrial uses of these minerals. We are recycling more and more of the mineral resources as time goes on, so that's that purple line in there. And then this last yellow line is our use of those primary metals, things like copper, iron, and things like that. So you can see that our mineral use also goes along with a lot of social patterns. So when you have a recession, we're going to start using less minerals, mostly in that construction realm, because people aren't going to develop as many areas, build new houses, that sort of thing. But there are also things that can kickstart mineral use, such as world wars, where we start to use more. So mineral use is such an important part of our everyday life, and these are just many different ways that the average person uses all these minerals in the US. And most of this, including the last graph, does not even consider those fuel minerals that we're using, mostly those fossil fuels. So these are just these other types of minerals, those metallic and non-metallic minerals, And you can see every single person is going to need to use a lot of these minerals. Of course, in the highly developed countries like the US, we use a lot more because we consume a lot more as a society. And all of these different things are ways that we are using these mineral resources throughout our life. So it takes quite a bit to support us. So some examples of that, these are just the minerals used in computer chips, and you can see that over time we've started to use more and more minerals in order to make our computers. If you just look at a cell phone alone, you find a tremendous amount of minerals. So here are some examples of some different things that they do in your cell phone, and they're really pretty indispensable to building something like a smartphone. And it costs quite a bit of money to manufacture all of these smartphones when you really consider having to extract and mine the mineral and then process it in order for it to get into your phone in the first place. If you really look at how much has to be mined to get that amount of gold or copper or silver, it's a tremendous amount of ore that we're going to have to mine to get that mineral out. And one of the problems here is that a lot of the minerals that are used in our electronics every day are something called rare earth metals. And they're called rare for a reason. They are not all that easy to find. And they're something that could be a concern in the future because we may eventually run out of them if we don't start recycling some of this material. One of the issues that goes along with this is that they are definitely not very evenly distributed throughout the world, and 90% of them are mined in China. So that brings a whole other social side of the issue. If you take a look, these rare earth minerals are generally the ones mostly in the lanthanide series of the periodic table, but you also have some semiconductors, some of those earth metals and things like that in there as well. And these are some of the many different things that they do. One thing I want to point out to you is that a lot of these rare earths are very important in many of our more energy efficient or renewable energy production methods. So this is something that we're also going to be relying on to try to come up with ways to be more environmentally sustainable. So this is something that we need to keep in mind, is we need to have a reliable source of these rare earth minerals. This is just one more example of all the different ways they're used in the military. So very, very important group of minerals, even though we don't have that much of them. And we've seen, as our technology has improved, the prices of these minerals has started to skyrocket. And as I said, China produces 90% of them. You can see this little top of the bar graph there is just what the rest of the world produces. And they have many, many different uses. Now you can see in the graph here that their price spiked right around 2010. And at that point, China started controlling a lot of what they were selling in terms of these rare earth minerals. So they kept basically keeping more for themselves for their own technologies, and that has made the price go up significantly on many of them. Gold and silver, not a rare earth, so that just kind of gives you a point of comparison. You can see how low those prices are compared to some of these. And of course that means that electronics get more expensive too if the minerals that are needed to make them are more expensive. So if you take a look at where these are produced in the world, of course you're going to see China being the major leader. The US can also produce some of these things, and we have in the past, but we've put it back into more of a reserve type resource for now, and we've kind of let other people take control. But that is an area where we could start to maybe exploit that a little bit more in the future. So this is just a kind of comparison here, and you can see, of course, China being the largest player one more time. But another interesting social issue is that Russia and the former Soviet states also have a edge over us in the rare earth mineral production and also the manufacturing of high-tech products in general. So this sets up a very interesting political event here. So as you can see, China is producing the most at the moment, followed by these 3 other countries, but a lot of different areas in the world have some of these minerals in reserve that they could then later on mine, and we would be one of them, but again, so would Russia. Alright, so let's move on from those for a second and talk about ores. So remember last time we said that an ore is a rock that you can extract usable minerals from, and there are high-grade ores and low-grade ores. So the higher the grade, the more of the mineral you can get out of it. So obviously you want to try to get to those highly concentrated ores because you're going to make a lot more money. It's going to be a lot easier to get the mineral out of that rock. But it can be possible with low-grade ores as well, and we're starting to see more and more of those being exploited as we run out of those high-grade ores. These are also just some examples for you of some different types of ores. So those would be these minerals right here, and then these are the pure metals that you're trying to extract from that ore, and you can see that those metals are part of the compound that makes up that mineral in the first place. Now there's a particular type of mineral I'd also like to mention here, and they're called conflict minerals, and they tend to be these 4 minerals in particular, so tantalum, tungsten, gold, and tin. And you can see that they have many different uses, especially electronics again, so they're very important. And there's a big conflict that has kind of surrounded these minerals in particular. And that is that there's been a huge civil war going on in Africa, in this Democratic Republic of the Congo, and this civil war has involved a lot of genocide and a lot of really nasty things happening to a lot of people. And this is basically being funded by mining of these particular minerals. So this has been an issue that in some ways has not been as publicized as it should be. It's one of the deadliest wars that has ever occurred. And it's all about these minerals, which we use every day. So you can see how these conflict minerals are used in various aspects of your life. This is just the average person. You would use these minerals for this amount of time every single day in these different arenas, including especially in your vehicles, and again, especially in those hybrid vehicles. So as I said, this is very deadly. You can see it here in comparison to the Korean War and the Vietnam War. This particular war has been a huge loss of life. But we use these minerals every day. So one thing that has been put in place to try to avoid us buying these conflict minerals is this act called the Dodd-Frank Wall Street Reform and Consumer Protection Act. And basically it requires companies to identify where these minerals that are being used in their products come from, so that hopefully we can start to see where we're using conflict minerals and start to try to avoid them. So it's already helped to reduce the revenue going to these militia groups in the Congo, but we have a long way to go. A lot of products still aren't labeled yet, and a lot of companies still aren't complying with this rule, so it has to be enforced as well. So one of the issues that we see, and the issue in Congo goes along with this, is that our mineral resources are distributed really unevenly around the globe. You can see that you tend to have pockets of certain minerals, like there's a lot of silver along this seam, a lot of gold in certain areas and things like that. And diamonds all through here in Africa. So a lot of these mineral resources are going to go to one particular country over the other, and of course that's going to create conflict. That's going to create a need to trade globally and to get along in order to do so. So this is just some of the major minerals, and it shows you kind of where they're produced. And again, I want to point out here how many are coming from China. And that really has the potential to give them some major political power in the future, especially when you start to look at how much the U.S. relies on other countries for these minerals. You can see that we are up to 100% reliant on many other countries for a lot of our mineral resources, and sometimes it's a little bit of a scary thing. So part of the reason why minerals are distributed so unevenly is the way that they form. So there are basically 4 major ways that mineral deposits can form, and we're going to list them and go through what they are. So the first one is called magmatic concentration, and basically this is happening as magma cools down and solidifies, and this is separating into layers. So this is part of the reason why we talked about the rock cycle already. So this would be kind of an igneous process. So the heaviest of those layers are going to settle on the bottom. Those things are going to have things like iron in them, which is very dense. And then the lighter ones are going to go on top. So those would be more things like silicates and some of those compounds that we talked about. So that's our first way. And then we also have hydrothermal processes. So hydrothermal, hydro water, thermal heat. So we're talking about hot water that's coming up through cracks in the Earth's crust, and it carries dissolved minerals with it. And when this solution comes in contact with cold water or with sulfur, it's going to start to crystallize, basically, and these minerals are going to start to come out. And the minerals are, at that point, especially if they've reacted with sulfur, they're insoluble in water, so that's going to help them to precipitate out. This is going to be responsible for a lot of different deposits of things like gold, silver, copper, lead, and zinc. And this happens a lot at those hydrothermal vents in the ocean floors, but it can also happen in cracks underneath the ground as well. Then the third type is sedimentation. So again, this is pretty similar to how sedimentary rock forms in general, but now we're talking about a very pure version of that sedimentary rock. So we have those weathered particles that have come from other areas and eroded, and now they're deposited as sediment, either on the banks of the rivers, the deltas, where the rivers meet the ocean, or on the seafloor. And when the hot and cold water meet, a lot of these minerals will fall out of solution, they'll solidify, and then of course, just like any other sedimentary rock, they can be compacted and cemented together until you get a solid layer of that mineral. And then our last type of mineral formation is evaporation. So this is just what it sounds like. You have minerals dissolved, and when water evaporates, the mineral gets left behind. So this happens a lot in small seas or lakes or ponds that do not have a very big outlet to the ocean, or in some cases have no outlet at all. So the water's going to evaporate, it's going to leave behind these things. This is traditionally how salt, especially sea salt, has been harvested. But you can see that it also gives us things like table salt, borax, gypsum, and things like that. This also happens a lot of times in caves, where the water will evaporate out of the cave area. So all of these minerals, as we said, are deposited in different ways, and they wind up in different areas, and this means that different economies are going to be more or less dependent on their mineral resources. So you can see in the US which states are the most dependent on those resources, and this particular graphic is from the mining industry. So it is talking about how important minerals are for us, and I think they have a good point here, is a lot of our economy really does depend on mineral resources. So the trick is not to stop mining entirely, but to find ways to make it more sustainable. So let's talk a little bit about some mining techniques and some environmental effects, and you're going to be researching this more with your classwork as well. So when we mine minerals, we're basically trying to extract them out of the ground to get that ore, and there's two basic ways to do that: surface mining and subsurface mining. And as I said, you're going to take a closer look at both of these. One of the vocabulary words that goes along with this that you should know is overburden. This is any soil or rock that's on top of the mineral deposit. So you have to remove that before you can get down to the particular mineral that you're looking for. Another vocabulary word that kind of goes along with this is spoil. So spoil is basically all of that overburden or any other stuff in the ground that you don't want. It's kind of like the mining version of bycatch. It's the stuff that you're going to kind of throw away. So it's crushed rock. You tend to, at that point, have taken out the topsoil, so there's not really an organic material in it. There's no real nutrients there. It tends to be very large, and that leads to very large chunks. That leads to a high evaporation rate, so water's not going to stay in it for very long. And there's really no vegetation growing there, so there's no cover for wildlife. It's not a productive ecosystem at that point once you have the spoils left behind. So a lot of times the spoil gets put into a bank or a pile, and the other problem with this is that it's very subject to erosion. It could wind up in the water supply very easily. You also wind up with these things called high walls, where you have a wall of dirt, and again, that's highly erodible, and that could wind up downstream of you as well. Another kind of environmental issue with this is one of the ways that they process it. So in order to get the actual mineral out of the ore, you need to do something called smelting, where basically they melt the ore and they separate it by boiling point so that they can get the pure metal out of that particular rock. And that process really causes some environmental issues. So this is done in this thing called a blast furnace, and you would use this to smelt things like iron ore, limestone rock, and something called coke, which is basically a modified coal that they use to produce fuel for this process. So they add these things to the top of the blast furnace up here, and they add heated air and oxygen at the bottom here, and then a chemical reaction takes place as this ore comes down through the blast furnace, and that iron ore is going to react with the coke, and it's going to form molten iron and carbon dioxide. And then the limestone that they're putting in there is going to react with impurities in the ore, and that's going to form a molten mixture that's called slag. So that's another vocabulary word that you should know. Both the molten iron and the slag start to collect at the bottom here, but the slag is less dense, so it's going to float on top of the molten iron. So at that point, you can separate them out and take them to different places. So that slag is waste that is going to basically become mine tailings that they're going to need to dispose of somewhere. And then the molten iron, of course, is what they're after. One of the problems with this process is that you have a lot of exhaust gases that contain things like sulfur compounds. And if you don't have an air pollution control device on this, those sulfur oxides are going to get up into the atmosphere. And remember, those are one of the major causes of acid rain. So that is going to be a major environmental impact there. Now, there are environmental impacts at every single step of this process. So the mining process itself, transporting the ore, actually using smelting and other processes to separate out the metals, and then actually making them into the products also emits more pollution, and then eventually that product is going to have used up its lifetime. So then what do we do with it at that point? That's another time where that can cause some negative environmental impacts. So one of those environmental impacts we want to focus on are the tailings, or that slag. 80% or more of that ore is going to be this waste that you don't actually need. And a lot of this is going to contain toxic materials, heavy metals, things like that, that you don't want to get into the ground supply. If it does, that can cause things like acid mine drainage. Smelting plants, as we said, emit large amounts of sulfur. That causes acid rain. It also requires a lot of energy to mine and smelt and produce mineral products. So that means you're burning a lot of fossil fuels generally. And of course, that can contribute more to climate change. It also means you're using more non-renewable resources. And eventually, at some point, you're going to have a solution for that. So tailings and spoils, again, kind of make up the waste of this mineral production process. And if you just look at the data here, this does not even include that overburden that we talked about, the stuff that they just kind of dug up and put off to the side. And you can see that very high amounts of the ore are actually waste products that don't actually get used. One of the other problems that tends to cause environmental issues is you use a lot of blasting, a lot of explosives at many of these places. And this can not always only cause noise pollution, but it's going to alter the environment. It's going to scare away animals and things like that. So here it shows you some of these different ways that the environment can be degraded by different mineral production or use processes. And you're going to be investigating this again in a little more detail, so some of these may go in the chart that you do later on. One of them I want to mention too, we've talked about already, is subsidence, which is when the ground collapses. This can happen if you have an underground mine and it's close enough to the surface that the ground can kind of sink in. Also, we talked about already, erosion is a big issue, especially those areas where you've cut down into mountains or things like that. It also uses large quantities of water. A lot of times these mines go below the water table, so they have to pump the water out of the mine to keep it dry. It can get contaminated in that process. We've talked already about acid mine drainage. So when those acids, when those heavy metals get into the water supply, that can come down and kill off organisms in the local area. And in addition, that processing step also often involves some very toxic chemicals that are being used to extract the metals that they want. So again, here are just some pictures of that acid mine drainage in particular. You can really visually see all of these chemicals that are in that area. So one particular case study here is Copper Basin in Tennessee. And this is an area that started off as a healthy forest, but then kind of progressed into a panorama of red, barren hills that kind of just baked in the sun and had very few plant and animal species, with these deep ruts that you can see going through the land here. So what happened here was during the middle of the 19th century, they found copper ore near this town of Ducktown. And what they did is they came in and extracted the ore, they mined it, they dug pits, and they actually used what's called an open air smelter. So in these pits, they were actually processing the ore. So obviously, if it's open air, they weren't really treating it for any of those sulfur oxides, and then that caused acid rain in the area. And the acid rain was so severe, along with the acid mine drainage and the other impacts, that basically the entire ecosystem died off in a few years. So first, the plants were killed on land. From that acid rain, and then once you don't have the plants, you've lost the basis of the food system, the whole food chain there, and you've also lost the roots that were holding all the soil in place. So this is why we had such levels of increased erosion here. And once all of the acid precipitation and those other chemicals got down into the streams, you caused that aquatic ecosystem to collapse as well. So this is something, it's one of the largest Superfund sites in the US, and it's something that's been addressed over several years, but it's still very bad. It has started to regenerate in certain areas, but this succession is going to be very slow because there are still a lot of toxic compounds in the area. So since we are so reliant on these mineral resources, it's really something that we need to keep track of, how we're using it and where our supply is going to come from. And one thing that you kind of notice and that it shows in this graph here is when you have a huge supply of the particular mineral, you're probably going to just keep mining it and just keep using it. But as time goes on and that supply decreases, especially if the demand for the product stays the same, it's going to encourage more recycling, more wise use of these mineral resources. So there are all types of ways that we can try to use these mineral resources sustainably. And these are just some examples here that I'd like you to read through and add to your notes. And I want to point out one particular way that looks very promising. And if we talked about those cell phones and all those minerals that are used in that, there are a lot of claims that basically this could be an even easier way to get minerals is by recycling these cell phones rather than mining them from the earth. And actually, when you do out the math, it does turn out that there are more minerals in these old cell phones than there is in a comparable amount of ore. So this is something that you're going to see more and more of in the future, and you should always try to make sure that you are recycling any of your old electronics. So this is becoming a huge growth industry. This is something that a lot of businesses are getting into because you can make a tremendous amount of money by getting these minerals back out of technology and recycling them and selling them back to become new technology again. Another thing that we're starting to see to try to use minerals more sustainably is an eco-industrial revolution, where we're trying to redesign industrial manufacturing to try to basically do something called biomimicry. You're mimicking the natural world and how it deals with waste. So you're trying to basically set up a cycle, like a carbon cycle or a nitrogen cycle would work in nature only with these particular minerals and different things. And this could involve lots of different things. We talked about it already with aquaculture, how the waste from the fish could be used to fertilize plants and things like that. But there's many different ways that we can cycle these things around, and this would include a lot of our mineral resources. So if we could create basically a sustainable industrial ecosystem, if you want to think about it that way, we can start to use these things much more wisely. So anytime we're talking about sustainable use of different resources, a lot of times it's going to come down to what we call the 3 R's, reducing, reusing, and recycling. So trying to reduce how much we use in the first place, reuse any of those resources that are still in the same state, and recycle anything so that we can reprocess it and put it back into our new products. All right, so make sure you have checked on Edline for your assignment, and you're going to be investigating some of these mining techniques in a little bit more detail. Thanks, and I'll see you later.